Hey all! So I got inspired by a question that I received from a friend, which is how to create a GUI inside Max using the jit.pworld object. So the jit.pworld object is this new object that was introduced, I think, in the latest version of Max, or it's a new feature of the GL3 package. I don't know exactly which one of the two, but one of those two. So either is in the last Max version or is inside the last GL3 package update. Either way, this object basically it's a jit.p window, but already contains inside a jit.pworld. So it's basically, if we give this object a name like my world, this is going to be the name of our GL context. So if now I draw a GGL grid shape to my world, this is drawn to this jit.p window. Because inside here there is actually a world. So the idea is to create a GUI, a graphic user interface, using the jit.pworld object. So this is called jit.pworld, which is definitely a cool idea. We can use, for example, this GUI in our Max for Life device or in our Max patches. And this object is perfectly fit to do that. I mean, we could have done it also before with a GGL render and a jit.p window. This would have worked the same way. But since this object has been introduced, it's a good excuse to use it to create a graphic user interface. So basically, yeah, we send it. Let's send it a name. Let's call it, for example, my world is going to be the name of our context. Let's send this at load bang. So it already has a name. So for example, I don't know, if we want to create like an arrow with our mouse, that when we stretch it, for example, it increases our pitch of synthesizer or something like that, and when we make it longer, increases the I don't know, the amplitude of the sound. Yeah, then we can do these kind of things. For example, let's start in fact with that. Let's start by creating an arrow that we can move using the mouse. So one thing we want to do is to get the size of this window in order to remap our mouse input between I don't know, 0 and 1 according to the size of the window. But first, before we do that, let's actually send it the idle mouse 1 attribute, which means then we are going to get the mouse position from the output here. Cool, so let's use a root object to actually route this message. So mouse idle zakity zak. Cool. And then actually let's send it the ortho2, but this, I think, it's not a message that this object understands. So let's actually try. No, it doesn't understand ortho, so we have actually to send this to the render inside the jit.pworld. So okay, now it's in ortho 2, which means it's not going to use the depth for the shapes created in this world. It's only going to be a two-dimensional world, and this is what we want, because then we can map exactly the mouse to the screen coordinates to the world coordinates. So from the screen coordinates, which are those ones here, to the world coordinates is going to be a one-to-one mapping. Very well. So what we have to send it then is to get the patching rect. So the patching rectangle is going to be basically the size of this window inside the patch, but actually it's get patching rect. Let's see. Yeah, okay. So let's actually route it, patching rect. Let's see what we get. Okay, nice. So this is our patching rect. Now the numbers we're interested in are these last two, which are width and height. So let's actually use a message box and take out only $3 and $4. And let's actually get another message box and get $1 and $2 here. Okay, so basically then we can use a vex object to make $f1 divided $f2. We are basically dividing one list by the other. So we should get now a list with our mouse coordinates remapped between 0 and 1. So let's see. If we go here, it should be 0 for the x, and 0 for the epsilon here on the top left corner. If we go all the way here, this is going to be 1 for the x and 1 for the epsilon. Yeah, that's as close as it gets. Cool. Okay, then good. Now we got our coordinates between 0 and 1. Great. Now let's do actually something like this. Let's unpack those two numbers, because actually we want to scale our epsilon coordinates between -1 and 1, because our world coordinates go between -1 and 1 here on the epsilon axis. So let's see actually which number we get here. Oh, it's the other way around. So let's scale them between 1 and -1. Let's see if this actually works. Okay, cool. So now we got 1 when we go all the way to the top, and 0 when we go, -1 when we go all the way to the bottom. Cool. And now we should actually multiply the x by the ratio. So in order to have it between minus ratio and ratio. So let's do like that. First we send the list on the right output here of this trigger object, and we divide the x by the epsilon, just like that. So we get the ratio. So we basically can scale then the x coordinates from 0, 1 to 1 to minus ratio to ratio. So we just put a placeholder of -1 and 1, but actually we are going to scale it for, multiply this by -1, and we're going to scale it by minus ratio and ratio. Yeah, this should do the trick. Let's see if it actually does the trick. So let's get the patching rect. Okay, so this will go all the way to minus ratio, which is -2 something, and then we'll go all the way up to ratio, which is 2 point something. Cool. So now we got our world coordinates. Let's pack them again together and call it like mouse boss 0, 0. And let's do something like that. Cool. So this is going to go probably inside our jit.gen. So let's now create a matrix. Let's now create a matrix with just 2 cells. So 3 float 32, because we need 3 planes for the coordinates, float 32, and 2 cells, because we're going just to create a line. So we basically just need 2 cells. And let's route actually the bang from this output here, the left output of the jit.pworld, because actually I think we get from here a bunch of stuff. Oh no, we just get a bang. Okay, cool, so we actually don't need even to route it. We can just send it here to this jit matrix, this bang. But just to be sure, let's actually route it. So route bang. Cool. And let's connect these to a jit.gen, which we are used to create the position of our line. And let's create a jit.gl mesh. Drawing to my world. Draw mode lines. No, line strip actually. And color, let's put it white. Cool. So let's connect this here. And let's go inside the jit.gen. Let's create a parameter. Let's call it mouse boss. And cool. Then let's create the normalized coordinates. So these normalized coordinates will go probably between 0 and 0.9 or something like that. Let's see what we get out of this. jit.cellblock. Let's see what we actually get out of here. So we get 0 and 1. Perfect. So basically we want to multiply those. Actually, let's create a vector here with 3 inputs, because this is going to be just a single number out of this norm, because it's only 1 dimension. So let's actually say concat to 0. So we get then a vector 3. Okay, cool. So now if we connect this here, let's see exactly. So we get a line that starts from 0 and arrives to our mouse position. Okay, cool. Okay, cool. Let's say that this is what we want. If we wanted to start from the beginning, we should actually subtract the ratio from the x of this value. Let's try to do that. Let's create a parameter ratio. Let's set it to 1. And then let's create here, let's say prepend ratio, and this is going to be our ratio. Goes inside this jit.gen ratio of the window. And let's say minus ratio 0, 0. Let's connect this here. And okay, that's it. Okay, no. This is wrong, this is wrong, this is wrong, because... okay, now let's do it like that. So let's not scale it between minus ratio and ratio. Let's actually scale it between 0 and ratio. So basically, let's just multiply this by ratio. So that, the x of the mouse, we multiply this by the ratio. Okay, good. So inside the jit.gen, then we can basically do this. Let's say, let's switch the x of our mouse position and the y. And then let's multiply, no, let's say scale 0 ratio to minus ratio ratio. I don't think this is the best way of doing it, but it's just the way I'm doing it. So let's actually scale this from here. Then let's multiply this by the normalized coordinates here. Then let's scale it. And let's create now a vector 3. So this is going to be our x value. Let's see if this actually works. Yeah, okay, cool, this works. And then let's get the y, let's multiply as well for the normalized coordinates. Zack, zack. Okay, so if you have a better way of rescaling those values, guys, please let me know, because I'm sure there is a better way of doing this. Just that for this thing, I'm going to use this way. So let's set actually the line width to something bigger, like 3, for example, and then we get a big fat line. Cool. So now basically we got a starting point of 0, and we got a length of this, basically this arrow, and we got a direction for the arrow. So we got an x and a y component. So let's maybe make it in a way that if we press the mouse, it's actually going to stop creating this line. Okay, yeah, so it's detaching the mouse from the line. So every time we press the left button of the mouse, it's going to detach from this line. So there should be something like the mouse idle actually should give us the mouse pressed inside the window. It doesn't do that. Okay, very well. No. Okay, mouse. You need to know that you need to use the mouse message. And then also we get the mouse idle out, which means that the mouse went out from the window. So, okay, let's route the mouse message and the mouse idle out messages. So, this is the mouse, this is the mouse idle. So cool, you're basically interested here only in... oh, you know what we can do actually? That the line gets created only when we actually press the mouse, then we modify the line. Yeah, this makes a bit more sense. So let's actually do like this. Let's switch $1 and $2 from here. And then let's switch as well $3. So let's do like this. Let's point this list into different places. On one side, we are just going to get... So first we are just going to get $3, which is the mouse click. And then we are going to get the coordinates, so if the mouse is pressed. So let's do it like this. Basically, if the mouse is pressed, we are going to open a gate that allows these coordinates to be changed. So basically, let's create a gate. Let's simply put it simply here, at the end of all this chain. Let's try. And let's connect this to the $3. So if I click and drag, then I'm going to modify this line. When I release the mouse, the line is not modified anymore. Okay, which sounds cool. Let's actually try to draw the coordinates, the x coordinates and the y coordinates of this line on the screen. So we can do that using, for example, a GGL text. So let's see, we can use a GGL text 2D. I think there is a little bug inside this GL3 version, which makes the GGL text2D not responding to the position attribute. But let's try. If it doesn't work, then we're going to use GGL text mode 3D. So let's see. Let's give it a text. Test. Okay, there it is. Let's try to move it with the position attribute. And in fact, it's not working. Okay, so we cannot use the GGL text 2D. It's going to use GGL text 3D. And let's give it the color white. Let's see how big this is. Oh, it's really big. So let's actually scale it to something smaller, like 0.1. Okay, cool. So basically, the position of this thing is going to be the mouse position. So let's basically pack this inside with a position word in front, basically preparing the position word. And let's give this position to the GGL text. Okay, cool. And oh, of course, now we need the position of the mouse into world coordinates. So actually, it was good to have it scaled in world coordinates. So it's a bit messy, but I will now scale it into world coordinates. I know this is a bit wrong, because this could be better done in another way, but until we find a better way to do it, then I will just do it like that. So this is scaled between minus ratio and ratio. This is getting a bit messy with this thing, so I will just start to use a trigger with a lot of F's. So first it sends it here, then it sends it there, then it sends it there, and then it sends it. Actually, it would be conceptually better to send it first there, and then here, and then last but not least, send it to the jit.gen. Okay, something like that. So scale, this is going to be our X position here. Alrighty. So let's give it a try. Okay, cool. Okay, yeah, this looks good. So basically our text now, it's going to be actually our mouse position. So actually we could choose to keep the X position between 0 and 1. So we can actually use this position coming out, this X position coming out directly from here for the text. So let's pack text ff, and we're going to use the X position and the Y position scale between -1 and 1. This probably makes sense. Cool. So let's give it a try. Okay, cool. So we get our X position between 0 and 1, and the Y position between -1 and 1. Now the problem is that if we go all the way to the right, they're going to disappear. Let's maybe just do it, then when we go on the right side, they cannot go above the edge of the screen. So it's actually even too many numbers. So we should actually reduce the precision of these numbers, and we can do that using, for example, how it's called, the sprintf object. Sprintf object, and we can say text $2f. No, it's not F, it's like, how is it called, C, or something like that, or D. I think it's D. So let me just try that. So if we do this, what do we get? Now D, I think, is integers, so we actually need F. Let me try. Oh yeah, but it's not giving us exactly, maybe it's $.2f, something like that. Yeah, exactly. So this will give us only 2 decimals for the precision. So let's do it like this, $.2f. Text, blah blah blah. So okay, so let's delete this. This is going to be our X, this is going to be our Y. So the Y is going to come from here. Okay, let's give it as a text. So we don't need. So perfect. Very well, very well. So let's actually now clamp the position of the text. So let's actually put it a bit more up compared to exactly to the mouse position. So let's do like that. Let's sum this 0.1 to that. or something like this. Exactly, so it's a bit more up. Now let's basically clamp the X position between, so clip between minus, no, let's do like this. Let's clip it between minus ratio and basically the ratio. So let's do like this. Add another F here, why not? The ratio minus something like 0.2. Just to clip it on that it never goes above the beyond the edge of the right edge of the screen. So let's give it a try. Okay, minus 2 is a bit too few, so let's say minus 4. Let's try again, and it's a bit better, but not yet it. So this is dependent from the size of your window, so it's probably there is a better way to do that as well. Okay, so that is cool. Never goes above, never goes beyond this edge, which is cool. Let's maybe do it like 0.6. And yeah, 0.6 looks good. Okay, cool. So this is going to be our coordinates. We can also clip actually the epsilon position that it never goes beyond minus 1 and 1. Let's actually do it with, instead of using scale, let's use zeta map, which will basically clamp it. Clamp the values. So let's see. Zeta map, it's not helping us. Ah, no, I think I scaled the wrong one. So let's scale it also here. Let's use it also here, zeta map, okay. And it's actually doing the other way around, the zeta map for some reason. So let's actually change it again. Oh, zeta map, you really are unfriendly. It's not doing it in the other way around. Okay, so let's simply subtract 1 to the output of zeta map. And, ooh. Ah, okay, of course, we don't have to subtract 1, we just have to multiply by minus 1, sorry. Okay, cool, so now it's clipped. And we probably have to find a way to not make it disappear here above as well, the text. We can just clip the text, but I think you got it, how this actually works. Now, yeah, basically we can use this as a GUI for something. For example, the one could be the amplitude. Oh, we should also clip the mouse values between 0 and 1 here, actually. So, but okay. Let's actually put on the text here, let's put, for example, X and Epsilon. Something like that. Yeah, this looks nice. Let's clip it then to minus 0.065. Yeah, 0.68, just to make it precise. Yeah, cool. Okay, and then we can use this stuff, for example, with a cycle object, like very stupid cycle object. We can basically get our X between 0 and 1, which comes out of here. Let's put a bunch of triggers also here, actually. Trigger FFF. So first it goes here, then it goes here, then it goes here. I just like to have triggers to make stuff a bit neater, so we actually know which order the stuff gets triggered. Okay, cool. So this is actually going to be between 0 and 1. So let's actually zeta map 0 and 1 between, I don't know, 300 and 1000. Create another thing, F. So this is going to be our frequency. No, sorry, let's zeta map minus 0 and 1. This is going to be our frequency. So this is going to be the epsilon value, which comes out of here. So here. Exactly. And then this is going to be our amplitude. So let's actually multiply it, the tilde, for the X value, which is the mouse X position. And okay, so let's give it a try. Let's see if this actually works. Okay, cool. So we are controlling the x-axis is controlling the amplitude, which goes between 0 and 1, actually goes even above 1. And then the epsilon is controlling the frequency. So this is going to be a frequency of 1000, this is going to be a frequency of 300. And amplitude equal to 0. Okay, so cool. Okay, let's stop this madness. Okay, so cool. Let's stop here with this thing. Maybe I'm going to continue it and making something, some cooler looking graphic user interface thing. But this is a good starting point, I think, if you want to go in this direction and develop your own graphic user interface using the jit.pworld object, which it's really cool for this goal. Okay, so yeah, this was totally improvised. Didn't really plan any of this, so it's a bit messy. But if you managed to go through all of the video, thank you very much for following. And if you wish to support me on Patreon, you know where to look for. Actually, I will put this patch in download the Patreons only, but you can either download it by becoming a Patreon or just recreate it yourself by following the video. So, thank you again, and see you soon in the next video. Ciao, ciao.